Have you ever seen a scary movie where there's a field and someone's being chased through the field, the crop rustling behind them, a killer unseen on their trail? It's pretty scary, right? Well, I've got an even scarier story of a killer in the field. I study serial killers. By cereal, I mean wheat and barley. By killers, I mean fungal pathogens. They cause devastating disease like crown rot and yellow spot every year in Australia. It may not sound very scary right now, but in a bad year, these pathogens can destroy the economy of a farm, a town, or the whole country. Worldwide, they can cause poverty, poisoning, even death. These pathogens are getting away with murder around the globe and right here in Australia. Our knowledge and control of these pathogens target the infection and disease process. Resistance breeding, fungicides, even social distancing for plants gives us some protection. Then, once the crop is grown, the grain is harvested, we can finally relax, right? But this is not the end. This is just the beginning. The pathogens I study can survive after harvest in the cereal straw, what we call stubble. They survive here for years without a living host, lying in wait for the next cereal crop. The problem is that farmers keep their stubble to improve soil health and are often forced to replant cereals in infected fields before the stubble and the pathogens within have decomposed. And so pathogen numbers continue to increase and the cycle continues. So how do we break the cycle? My research explores how we can gain control of pathogens in the stubble when the plant is dead, but the pathogens are still very much alive. The activity of these pathogens in stubble is still a mystery, but it might hold the key to breaking the cycle. I aim to find out what conditions help these pathogens thrive or not in the stubble, and study the effects of modern farming practices have on these pathogens after harvest. With this knowledge, we can start to identify and exploit pathogen weaknesses. For example, I found that these pathogens can climb from 0.4 to 1 centimetres per day under ideal conditions in stubble. So, one management option might be cutting the stubble shorter and stop those pathogens from climbing and the situation getting any worse. I also aim to investigate a novel strategy using microwave radiation to destroy the pathogens in stubble, importantly without destroying the stubble itself. I already have evidence that both of these strategies are promising at the field level. This research could be the start of the next generation of field control, stopping the pathogen before infection can even take place, stopping these serial killers in their tracks.